So this is Bulletproof, your JavaScript application with TypeScript. So I'm Andrew Carver. A little bit about myself. I'm a developer over at Allstate Benefits. We have a booth here, so if any of the tech that I'm showing today is interesting to you, feel free to drop by and hang out with us. I'm a senior software developer over there. It's my email if you ever need to reach out to me. I also have a GitHub repo I'll post with Code on the Beach, so you can see some of the code here that we have. And as I mentioned before, if you have any questions or anything, feel free to chime in as I go along so everybody can follow along. Perfect. All right. Cool. All right, it works. All right, so today's agenda. So I'm going to go over what TypeScript is. So if you've never used it before, don't feel worried. I'm going to touch on what it is. We'll go through some of the basic syntax. I'm going to go over TypeScript best practices. So I'm going to show a React application with TypeScript woven throughout it so you can see what it looks like as you work with it in VS Code. And then at the end, I'll go with a little bit of an interesting approach based off of Scott Woloshin's work with F#, type-driven development. So we'll see how we can make our application, use the type system fully with TypeScript to make our application even more robust. And so that'll make a little bit more sense as we get into it. All right. So I feel like I should start this off a little bit like a lawyer infomercial. So if you ever worked with JavaScript, a large JavaScript application, and eventually it reaches a point where you basically have no type safety. So you find that you have bugs all the time, you write a ton of unit tests, but it's not a strongly typed language. So it's very difficult to keep things straight. Eventually just snowballs and snowballs. So then you have to live in a constant state of paranoia. As it mentions here too, it's very difficult to refactor. VS Code and other tools like that can try to refactor, but since it's not strongly typed, it's very difficult to make changes. Even if you want to rename a variable, see usages and stuff like that, it'll try its best, but it's not a strongly typed language. All right. So oftentimes I've worked on a large JavaScript application before moving to TypeScript, and this was about the development cycle that I ran through. So I'd write my code, I'd run it, and then I'd kind of cover my eyes partially and click nervously on everything and hope that I didn't break anything. And it can be very troublesome because maybe if you use components everywhere, you may not realize you broke something. So you just have to keep running through that cycle over and over and over again, and you end up basically oh, come on. All right. There we go. All right. Yep. So you end up basically mashing refresh all the time and just hoping that you did not break production. With that introduction, what is TypeScript and how can it help that situation? So TypeScript, as the slide says, is a typed superset of JavaScript that compiles to plain JavaScript. And so what that means, breaking that down, is that it is strongly typed, as it mentions. It's a superset, so all JavaScript is valid TypeScript. TypeScript kind of sits on top of it and gives you type safety, and it compiles down to plain JavaScript. So at the end of the day, it's running a TypeScript compiler, it's exporting out JavaScript, so that's what gets shipped. Let's move on. All right, so a little bit about who uses it. I mean, this is just a short list. A lot of people use it. It's getting a lot more popular. I think I saw in some ranking hierarchy, Red Monk or something like that is number 10 on their list. I don't know how they come up with their numbers, but needless to say, it's growing a lot in popularity. Anybody that is involved in the JavaScript ecosystem can see a lot of libraries are now shipping with their own type definitions, so you don't have to specify your own type definition for those libraries and get all the benefits. This is a pretty short list, but I'm sure we've all used some of these products, or are pretty familiar with some of them. All right. So why use it? So as I mentioned before, with JavaScript, you have no compile time safety. So everything's dynamically typed. So you have to hope that you spelled things correctly, that everything looks good. With this, you can verify that if it compiles, it hopefully should run. You can refactor much easier since they're all symbols and it's strongly typed. If you need to rename something, you get all that wonderful refactoring capabilities that you're used to in C# and other strongly typed languages. My personal favorite, autocomplete. So no more having to remember what you named something. So yes, rejoice. So yes. All right. So if you never used TypeScript before, fear not. I will go through some high-level syntax of TypeScript. So I'll give you the Cliff Notes version of TypeScript here. So if you've never seen it before, I'm not going to start showing you a language that you've never seen. We'll go through it a little bit. So basic syntax of TypeScript. So as you can see here, I have a very simple function that I'm defining. You see the colons after the variables there. So those colons are basically telling TypeScript what type that parameter is. So number1 is a number, num2 is a number, and then the colon at the end of that lambda there is the return type. So I'm telling TypeScript that this also returns a number. TypeScript can infer some of these things, as we'll see. So sometimes you may not have to annotate types. So it's kind of a as you develop a TypeScript, just kind of you can watch the types in your IDE and see what it thinks things are. There are times where you want to specify something as a return type. In this case, you probably wouldn't have to since you're providing two numbers and adding them together. But as we get into like Redux reducers and stuff like that, that extra type annotation can actually help because you can basically tell the compiler this should be this type. And then if you added number1, number2 together in another string, it would say, yeah, that's not a number, and then give you a compile time error. So just a little bit to think about there. So here's a list of the TypeScript basic types. So as you can see, some of these are probably familiar with you, seem very similar to other primitives in other languages. I want to call attention to a few of them that may kind of raise your eyebrow if you've never seen this before. So we got, of course, the Boolean, number, string, tuple, array, union. Any type, it might seem a little strange. So what that's doing is it's basically you're telling TypeScript this, I don't want you to infer anything about this. Treat this as almost like dynamic in C#. You're basically telling the compiler, leave this alone and ignore any types against it. I'm just going to roll with it. And so obviously you want to use that very sparingly because you're basically, ejecting out of TypeScript and then you're just, Wild West. So you're on your own. Right, yes, thank you. Right, yep, yeah, exactly. So then you don't get any of the benefits of TypeScript. So definitely something to use very sparingly. Void, the absence of a return value. Null and undefined are separate types in TypeScript. There's the never type, which is also a little different. That is basically, you'll see, it's a function that never actually returns anything. So if you throw an exception within a function, you'll see it returns never. So it's the absence of a return, different from void. Void is a function that does return, but it just gives you nothing. Never is, it doesn't come back. So, yep. All right. So you may say, all right, that's great, but what about creating new types? How do I do that? So there's three main different ways in TypeScript that you can create new types. So this is the type syntax. It kind of looks similar to F#, if you've seen that, or some other languages here. So I'm declaring a type here, to-do item. I'm using the almost JSON-like notation here, declaring that this type has two properties on it, to-do list, to-do text, and is completed. And then I'm annotating with primitive values there, but it's a pretty straightforward way of creating a type. We also have interfaces in TypeScript here. So interface, difference between an interface and a type. Classes can extend an interface, whereas the type they cannot. So that's one distinction between the two. We'll see another difference between them in a second. So in the third way, main way is class. So that's also a type itself as well. So it's pretty familiar to anybody that's done the object-oriented language. So you can also see too, a little side note here. So these read-only values that I have here within the constructor, you don't see that in JavaScript. That's a shorthand. So essentially I'm saying that it's equivalent to essentially creating a variable, a private variable up above and then assigning it. So I'm just saying there's a public read-only value, and then it's syntactic sugar, and it just creates a class for me there. So I can just one-line it. All right. So now we're getting to some interesting parts of TypeScript. So TypeScript has ways of representing what are known as product types and sum types. And if you've never seen these before, I'm sure you're familiar with the concept here. But here I'm using, so this is exclusive to assigning to a type itself. So here in TypeScript, I'm essentially saying there is this type here, user component props, that is the union of both of these types here. Essentially, I'm pulling from the route component props type and a type that contains the user ID string, and I'm ANDing them together. So it's the union of both. And that's very helpful, especially if you like to use a concrete example with Redux and React. If you have a component that you are passing props into, oftentimes, like the route component props here, libraries will extend their types out from their type definitions, and you can use the AND operator to pull them in. So you have the advantage of not having to type as much. You just pull straight from the type definitions. So this combines the two, and so as you might surmise, a sum type is the opposite of that. So I'm essentially saying there's an or. So a user ID could be a string or a number. Both are valid. Anything other than that, and it's a compile time error. Additionally, it doesn't have to be a primitive value. You could also say it's these 3 other types that I've defined somewhere else in the file. So I could say it could be an email that's valid, invalid, or unvalidated. So it's one of those 3 those distinct types and choices. We'll see how we can leverage that fully in a little bit. Any questions thus far? Hopefully.
You're probably using like the latest version of TypeScript, some of this stuff.
Oh, okay. Yep. Yeah. Cool.
TypeScript the past couple years.
Yes. Yep. So yeah. Yep. And it depends on what you're using TypeScript for. So you may not have seen these used. I know with React they use it with props.
Just so people know, the valid and invalid, those are custom types.
Yes. Thank you. Yes. That's what I was trying to point out. So yes. Thank you. So you can have your own types. You can then represent. Yes, exactly. It's like Inception. Yes, perfect. All right, so pattern matching. So you may say, with all these wonderful types, I've used languages like F#, and other, Scala, stuff like that. I like my pattern matching. Well, unfortunately, TypeScript doesn't have pattern matching out of the box, so brown face. But we do have tagged unions, and so you may ask, well, what are tagged unions? So tagged unions allow you to infer the type based on properties. So if you tell TypeScript, for instance, if there's one property that is distinct to a certain type within that union, TypeScript can figure out, oh, well, the only property with that, or type with that property value is this one, so I'm picking this one. And to give a little bit of more concrete example, so hopefully this makes a little bit more sense. So in a Redux reducer, it's a function that takes a state and an action and then returns a new state. So that action type that you use with the standard action structure, that is unique for each action. So with TypeScript, it's able to figure out, well, oh, if he's doing add to do, then that must be a add to do action, and then it knows the structure and it can figure it out. So we can figure out how to leverage that a little bit. So it's not quite pattern matching, but you can leverage that. So then TypeScript will figure out and assume that this action now is strongly typed. So I get the IntelliSense and everything along with it. Hopefully that makes sense. All right, any questions? Perfect. All right, so another thing to mention here, utility types. So TypeScript actually has utility types that it exports, and what those are is they allow you to transform existing types into new types. So, for instance, you can basically, it's kind of the lazy man's way of defining type definitions. So you'll see here, I'll go to the TypeScript site here. So we have several of them here. Some really interesting ones to look at. Extract, include, omit, return type. This is one you'll find you'll use all the time. So you can actually pull out the type of the function that you give it. So why I highlight this is that you may have found, and I've heard from other people, that in earlier versions of TypeScript, whenever they didn't have this, they found that they were defining types all the time. And at that point, it gets very hard to maintain. But with this, you can basically point it at a function and say, whatever the return type of this is, that's what this type is. And so then as somebody updates that function, you don't have to go back and redefine that type. It's pulling it straight out of what you defined it as. So using these and leveraging these utility types, you can do a lot of very interesting things, but it helps the maintainability of your code. So you don't have to continue to maintain all of these types all the time. But you get the advantages of TypeScript. So perfect. So and we'll see some of that in some of the examples I have. All right. All right, so let's get into a little demo here. I'm going to pull up VS Code and we'll see what it looks like. So we can see it in action. All right, so I have a very simple application here that I've created for a demo. So I'm going to go ahead and start it up. As it's starting up, I'm going to go over here to my little form here. So this is a very simple sign-up form application. Oh, thank you, Node. All right, perfect. So you can see here, so this is a very simple React application, but as I start hovering over these types that I've annotated in my code, VS Code is giving me all the IntelliSense that I wouldn't have otherwise. So I can see what the type of my props are being passed in. You can see that I'm using and leveraging type of operators here. So as I was mentioning, the return type utility function. I highly recommend if you use TypeScript to try to do that as much as you can. It helps a ton, because then as somebody updates these functions, I don't have to go chase down type definitions everywhere. I can essentially just have it pull straight from the function definition, then it can break and then tell me, hey, this definition has changed and this doesn't work anymore. You need to fix this file. So it helps refactoring a lot. All right, so let's look at the code here. All right, so it's a very basic sign-up form. I created this example here just to kind of illustrate a simple business use case. So we've all written a sign-up form, pretty straightforward. I'm going to type an email in here. So you see there's validations that are triggering on my form here. So once I fill in a valid email, it gives me a little check mark. I didn't mask the password, just so you guys can see that I'm meeting the rules. So I have a couple rules defined. Must have one uppercase, lowercase, number, symbol, you know. All right, yep, and then they got to match. So in this application, all right, so now everything looks good. I'm going to click sign up, and then it's going to tell me sign up was successful. You know, I sent an email. It's not actually sending an email, but just for the client side part of this demo, that's what it's doing. Perfect. All right. So getting into the code here. So what does the code look like? So it's a standard React Redux application. So I went over the props here in a second, or previously. So pretty standard. Using Material UI. Got text fields defined here. Got all my inputs. Let's go over to the reducer here really quick. A couple things I want to highlight. So if you use Redux, just to kind of toss it out, a couple little quick benefit, like maximum benefit for little effort. Typing your reducer tree. I have one reducer right now, but if you have, you know, of course, you're going to have several reducers with a large size application. This one-liner will actually pull out the entire type structure of your reducer tree. So I just point at my root reducer function and use the return type utility type, and then I get the entire reducer state for free. So it's very nice. Yeah, and then you don't have to remember, because I've caused so many bugs. I'm sure you have too if you use Redux, forgetting what you've named a property, forgetting what you named a reducer. You don't have to remember that anymore. You can essentially just one-liner that guy, and then you're done. You see I'm exporting the type, so you just same syntax as you would expect, and then you just import the type definition wherever you need it. All right, perfect. All right, so you see my reducer here. I had to type a couple things here. So my reducer state, I had to type. Then my actions as well. So again, leveraging return type. Return type is one that you'll use a lot. So here I've got several primitives that I'm typing for my reducer state here. As I was mentioning previously, on the reducer function here. So annotating return types like this can help a lot, because as you'll see here, if I pull this out, so let me assign this to a variable here. All right, and export this out. All right, so you can see here, so it knows there's a function that goes to user reducer state. If I pull this out, and then I return something other than the default state here, like maybe a string, and then I go back and I actually use a string value. Yep. So yeah, so you can see it's empty string or a reducer state. So if I were to then use this reducer in other places and start pulling properties off of it, I might not catch it in this file. So paying attention to those boundaries and annotating it correctly here can help save me some trouble later on. So whenever you can with your reducers, I would definitely recommend typing the return value in any function like that you know it's going to be a certain value all the time. All right, perfect. Okay, any questions thus far? All right, perfect.
You might want to increase the size of your...
Thank you, yes. Yeah, hopefully you guys in the back, you guys able to see okay? That good?
Oh, one more.
One more? Okay, here. How about this? There we go. All right, perfect. Okay, yep. All right. One more? Okay, there we go. Hopefully, good? Perfect. Okay, so, and yeah, okay, so hopefully nobody has any questions. So I'll go ahead and, before I go back to my slides, so kind of point out a few things that I've noticed. So whenever I originally went to TypeScript and started playing with it, I noticed that in a lot of my JavaScript applications, I was kind of paranoid about breaking things. So I stuck with a lot of primitive values, especially like in my reducers. So as you can see here in my reducer, I'm not really a fan of, we'll refactor this in a bit, but I noticed that I stuck to a lot of primitive values like this, and that basically led to very non-expressive or maintainable code. So it's very difficult, especially like talking like using a lot of flags, a lot of toggles, things that we probably wouldn't do in C# object-oriented programming. You can write unit tests and stuff around this, but with TypeScript, we now have the freedom to basically define complex objects and complex types, and we get compile time safety. So you no longer have to live in fear of that. So I'll show how that can be refactored in a second. All right, so let's get back to the slides here. All right.
TSLint, you shouldn't even need to compile time safety.
Yeah, TSLint will catch some things. Well, so TSLint will enforce linting best practices. So, and then the TypeScript. And TypeScript compiler. So between the two of them, TSLint is a great tool to use. So that'll catch a lot of little things that you made. You know, it'll look out for you. So, yep, excellent. All right, so perfect. So, yep. One thing to note, so it is a compile time error in TypeScript if you do not have type definitions for a library. So if you ever pull down your favorite library and then you notice that TypeScript's yelling at you saying, I can't find type definitions when you go to import it, that's what it's complaining about. But don't worry if it's not included in the library. There's this GitHub project out there called Definitely Typed. And it's essentially a centralized repository holding a bunch of submitted type definitions for very popular libraries out there. The syntax for that is @types, I believe, / and then your library name. That's usually the syntax that they go with. So definitely check that first. If you go pull in a library, then you notice you get that error. Yep, I actually have a link here to show off where it's at, just so you can see. High quality TypeScript definitions. So, and it's pretty, it's got a lot there. So chances are it's probably in there. Obviously, first case, a lot of libraries ship with their own TypeScript definitions. But if it's not there, that's your guy. All right. Perfect. So as I was mentioning, I noticed whenever I was working with JavaScript, again, I stuck with very shallow objects and a lot of flags, just trying to keep things as simple as possible because I was scared about nested objects, right? We all love the undefined is not a function or undefined is not a property in Chrome, and then the white screens or gives you a nice little error page. So it's really primitive obsession. But now that we can define much more complicated objects, we can leverage the TypeScript type system to help us out there. Again, difficult to maintain state. It's hard to discover business logic as well. So as I was showing off with that Redux reducer, I had several flags here that I was using hopefully the person coming behind me sees it, but they may not. They may not know to check the flag of is email valid or respect it, especially if I go back here really quick. To the sign up form here. So I'll make this big for the people in the back. All right. Yep. So I've got a lot of bleed through here. So I could abstract this out to a function. I kind of purposely engineered this example to highlight this problem. But you can see here. So I've got a lot of my business logic bleeding through into my presentation component, and I'm having to check a lot of flags and enforce a lot of business rules here that I'm not really a fan of doing. And hopefully the person coming behind me sees this, but they may or may not. Definitely something to highlight. All right, so how can we fix this? So type-driven development. So I don't know if you've heard the term before, but essentially it has very similar goals to test-driven development. And the idea is that essentially you can leverage a type system to help maintain your business logic. So to quote somebody, make illegal states unrepresentable by Aaron Minsky. So it's a very, the concept is that you weave your business rules into your type system. So you force, for example, as I mentioned in the type slide earlier, an email. It can be valid, invalid, or I haven't checked yet. Those are different states. So if we start thinking about our application in terms of a state machine, we would describe things like that. If I were describing it to a business person, I would say, what do you want to do whenever the email's invalid? What do we do? We don't speak in generic terms like that or speak about flags. We talk about it's a thing and it's invalid or valid. So those are all different states within our application, and we can put that in our type system. So again, thinking about it, if we start thinking about it as a state machine, type-driven development, these are all different types. So if you're ever wondering how can I apply this concept to my business problem, that's a really good way to thinking about it. Thinking through the different states, thinking about how the progression goes through, and then you have your types. Yep. So, for example, email in the example that we were just looking at. So we have a empty, or I haven't checked yet. We have an invalid, and then we have a valid email. And so one clever pattern that Scott Washington goes over in his book on domain-driven design in F#, I highly recommend it. Great book. But essentially the pattern that he follows is he basically has a public static creation function on his valid type where he enforces his business rules, so his invariants. The reason that you do that is that you basically force anybody that wants to create an instance of a valid email to go through this function. So nobody can create an instance of a valid email without going through this function. And so that makes it very easy for programmers coming behind you because they know that, oh, well, this function right here takes a valid email. How do I get one? Here it is. And then the constructor is private, so they have to go through that. So it creates one place. And you'll notice here in the return type of this function, I purposely tell TypeScript it's an email. So I don't know, it may be invalid that's coming out of this. So we'll see in a second how we can force the consumers of this function to respect that, because that's oftentimes, I think, where a lot of, especially as solving business problems, that's a lot of the times that it'll bite you, where you don't realize, oh, well, I didn't know what to do, when I didn't think about whenever the email was invalid, and then we get a nice little error. So if we can let the compiler know that, hey, this may or may not be what I think, it may not be a valid email coming back, we can force the compiler to tell us in our code, yeah, you can't actually save that because that's not I don't know for sure that that's an instance of a valid email. You need to do something to tell me that it is. So. It's a brilliant coding pattern. I never thought about that. Yeah, it's very, very clever. Yeah. Oh man, it gets good. So, yeah, I love this stuff. So, yeah. So, but again, you might think in F# if you use F# or other languages like that, I would just use pattern matching, right? But then, again, I said, there is no pattern matching in TypeScript. So we have the tagged unions, but we'll need to write our own match function. But I'll show you how we can leverage some of TypeScript's utility types to generate and help generate these pattern matching functions for us. It'll make sense in a second, but it's not a core feature of the language. But let's look at a refined demo. All right. So exact same kind of, let me make sure to kill my process here so I'm not bound to the same port. Perfect. And all right, there we go. Fire that up. Perfect. Yep, so as I was mentioning, and let me blow this up for the guys in the back. All right. So here, I have an email type here. So I'm defining it as I'm using the discriminated union. So I'm saying an email could be any one of these three states: an invalid email, a valid email, or I don't know yet. I just, because we don't want to yell at the user initially when they load the form. They've not done anything. You can't give me errors when I've not done anything. So, yep. And this is our match expression here that I've mentioned. So you'll notice on all these types that I've created here, I'm using a key value, key property. So you can. This is an approach that I found useful. So essentially just creating my own unique property value, and that allows me to discriminate on it. And you can see with TypeScript here, as I write my match function here, I now know that it's a case initial. It's an initial email. It's an invalid email. It's a valid email. I'm able to use that property to discriminate on it. So I'm able to generate basically a pattern matching function, so that way I can match across it. Does that make sense? Any questions? All right, perfect. All right, so getting into the options here. So I've cobbled this together based on some transformations that I found online. We'll go over a library in a second that can also help with this, but here we're getting into it. So this is a little bit scary looking. If you do not like generics, this might look a little bit intimidating. But what essentially this is doing is it's mapping over a type that I give it. It's going through every property in that union that I've given it, and then it's generating a type at the end of it. So this return function type here that I have, where I have an input and an output, it's mapping over these. So I'm describing what that type looks like in TypeScript. So the TypeScript actually is very deceptively powerful in this capability. So you can do a lot with this, and we'll go into show some libraries that other people have created that can do some really, really cool stuff. But essentially that's what I'm doing here. That's how I'm generating the options here. So you can see here, I'm saying the email match options, all three, I need a JSON object that supplies 3 functions here, invalid, valid, and initial, and I describe what the function signatures look like. I'm able to do that all in one line with TypeScript. So using those utility functions. So hopefully that makes sense. Questions?
Look how he's part of TypeScript, right?
Yes. So you can get lost in it. Yep.
Does it break if you forget a case?
Excellent question. Yes, it does. Perfect. Yeah. So actually, I'll go find a reference to this, and we'll look at it. So you can see here. So in my presentation component now, as you can see, so now I don't have any of the business logic living there as far as looking at tons of flags and stuff. I'm in my presentation component just purely saying, oh, when I have an invalid email, show errors. And then I have the errors in scope because it knows that the invalid email type is the one with errors, and I've matched against it. For the valid type, of course, I don't want to say anything. And if the user does not supply anything, I don't want anything. Yep. And if I pull this out, as you can see, I get the nice little nasty error message that says, yeah, I can't pull this into the type that you think it is because it doesn't match. The property initial's missing. So as a side note, TypeScript, sometimes can be a little bit verbose, especially if you start trying to do a lot of type transformations like this. I have noticed that you'll get sometimes a very nice cascading error message of I can't assign this, it's not assignable to, and then it just keeps going, and then you have no clue. You've done something wrong, but you don't know where. So it's something to keep in mind. Sometimes the error messages can be a little bit cryptic. In this case, it's pretty straightforward, but I'm sure they'll patch it up as they go. But for the most part, it's pretty good at catching those things. Yep. So as you can see here, so I'm matching against all of these different, or the case here that I needed for an invalid user email, invalid password, should be matching. Yep. So yeah. So if it's an instance of a valid password, show the green check mark, and then down at the bottom, instead of that nasty use of flags there or trying to put some kind of function, I can just basically say, oh yeah, is it a complete user? If it is, then enable the button. So I can use the types to drive my presentation component, and I've separated the two. The code is a lot cleaner and easier to maintain. And as you can see, if I get into this here, so in these creation functions here, I'm just basically using these matching expressions all throughout. So I'm able to accept name information, email, password, match against it. It returns a type of user. So you can do this all the way down, and then all of your business rules are basically expressed in types. So you can't forget a case, basically. It looks a little bit verbose, but you are rest assured that whenever it compiles, you've handled every case. You've walked through every case. So you know exactly what you're working with at every point in time. So hopefully that makes sense. Any questions? Perfect. Okay. All right, you can see at the bottom here, so I have a saved user state. So let's go back to the demo here that we've got. So it looks exactly the same, but I will do something a little bit different this time. I will open the Redux Dev Tools here. Hopefully I close the right tab. We'll find out in a second. All right, I'm going to fill this out. Yep, now it works exactly the same. All right. Perfect. Yep. And so hopefully for you folks in the back, let me blow this up a little bit. So you can see here, so this key you can kind of almost think of as a type that you can, it's a string value, but it essentially correlates to the type of that object that I'm using here. But you can see the type is actually changing. So the minute that I supplied a valid password, I'd filled out all the other values, and so I met all my business requirements. The password was complete, email was valid, I had data and everything, so it's good to go. And so the type actually changes to complete. So it makes it a lot easier to debug and look at because I'm using the TypeScript's type system to basically drive all those business rules for me. And in the Redux Dev Tools itself, I can see the type changing. So Here, whenever I go to save, it turns to a save state. So it makes it very easy to think about rather than thinking about a bunch of Boolean flags and other values that maybe shallow objects in my reducer.
So it's showing you steps of how things are changing.
Exactly. So yep, exactly. So it's as you and I would think about it. So because that person didn't supply a valid password, it's an invalid password. Therefore, it's not a complete user information. So, yep, exactly. So, perfect. Any questions? Yep.
So I learned about Vue.js about a couple hours ago, and I see some similarities and differences to TypeScript, and I could be comparing apples and oranges. What is the difference between these two things, and how might you integrate them together?
That's a good question. So I've not used Vue with TypeScript. So TypeScript itself is it's a strongly typed language. So TypeScript is a superset of JavaScript. So you can type any JavaScript with TypeScript. So but Vue is a framework. So it's essentially like React. So that would be the equivalent here.
Okay.
It would be React versus Vue. But yep. So whatever you use though, I mean, obviously I might be a little biased, but I love TypeScript. So I'd highly recommend TypeScript with it. It will save your bacon. So. All right. Yep. So, yep. Exactly. All right. So, yep. So as we can see, well, we were able to centralize our business logic with that approach. Our type signatures can now be honest with TypeScript, so we can use it fully. So as I was mentioning, so you're now dealing with concrete types in your match expressions. So you're able to say, I can only save a valid user. I can only interact in this way with a valid password. Or if it's an invalid password, show errors. So it's a lot easier for programmers to come behind you to read and reason about. It's easier for you to think about. The presentation code is a lot easier to read. All around, it's a lot easier to use. We're leveraging TypeScript to its full. So you can even think more abstractly about this. I included this as well. So even for a non-concrete field, but like async states, like if I'm fetching from an API, that's a state machine, right? I start off empty, I'm loading, then I wait for it to load, and then I resolve either to a loaded value, or I typed in the wrong endpoint and I get an error message. Those are all different states within your state machine. You can match against it. If you use a type like that, you could then have, for an instance, if you had user information you're fetching from an API in async of, with brackets, user information as a generic that you're passing in, then you can force anything that consumes that to match against it. So nobody can essentially try to access something before it's loaded. You're forcing people that come behind you to see that it's an asynchronous something. And they can't just reach in and grab it. They have to tell the UI or whatever they're, whenever they're trying to access it, they have to describe what happens if it's loading, what happens if it's got an error message. So you can't, so you don't have to, you let the compiler tell you if you forgot something. So, and it can help you out. The compiler's your friend. So, as I was mentioning, there are libraries out there as well that are very helpful on this topic. So one popular one that I've used a lot is Unionize. So essentially, this library allows you to define a type discriminated union, as you can see here in this syntax. So I'm describing a discriminated union of contact information. So I have phone number, email address, mailing address here. He has these of-type helpers that pull the type out. So you have to follow his pattern here. But what this library will do for you is it will generate a match expression for you. So the one-liner that I showed you is useful if you have business rules to enforce. But if you're just purely looking to define a union without any, because I made the constructor private in that one. So essentially, this is just using types, not classes. So if you need to enforce business invariants like I did, use a class, use that approach. If you just have simple data types, that it could be any one of those types and there's no rules attached to it, Unionize is your friend. It can generate that match expression for you. Here you can see, so I have some of the syntax here. You can pull the union out, and this is what the match expression would look like whenever you use it. So it's very helpful as well. Another very helpful tool to use. Yep. Another library that I found very interesting in TypeScript, Monocle. So I don't know if you've seen the concept of lenses, but this the author of this has pulled in and ported, essentially he's converted to TypeScript lenses from a popular library in Scala. what this allows you to do, so have you ever tried to modify that one property, like in this case, I need to alter the name of a street, so then I have to use all this arrow code here and tons of operators. It's a mess. Like seeing that is very difficult, as a developer to run across. So what Lenses can do for you, you can essentially, this is all type safe. So whenever you use this library, you can see here. So I'm composing together different lenses, so then I can actually do the same operation here. I can just modify that one field, and then I'm done. And as you can see, you can reuse lenses as well. So if you, in another line need to modify the address name or zip code, you can use that lens. So it's all reusable and composable, and it cleans up your code a bit. So very interesting library to check out. Highly recommend it. Yep. One that I've also been playing with, so I love functional programming. I always love going to these functional programming talks. One challenge I think that everybody faces is that how do you convince everybody going back to work that you need to switch to Haskell or F#? Probably not going to go so well. So learn a whole new language. But if you're interested in playing with higher kinded types, this library might be of interest to you. So right, yeah, exactly. Yeah, you might have a hard time pitching to your boss that we need to switch to this obscure language that nobody, right, exactly. I mean, right. Right, yep. They're going to, curse you and so, yep. So, but if you're interested in playing with the concept, FPTS has ported higher kinded types into TypeScript. Higher kinded types are not supported by TypeScript out of the box. So if you've never heard of higher kinded types, they're like generics for your generics. I know that sounds a little bit mind-bending, but rest assured, that's not actually what, again, the language doesn't support it, so he's using a technique called defunctionalization. I tried to read a little bit of it. He has a PhD link, white paper that he linked, and I read, first 3 paragraphs, and, my hair's on fire, and it's like, I'll take your word for it. But the concepts are very cool. So for instance, as you can see here, so I have some code here. So there's a concept called an either. And so it's a type itself that represents a choice. So you can see here, so I'm grabbing from an API, I'm mapping across it, and I'm grabbing a value out of the payload, and I'm setting it. But how do you merge the concept between a happy path and a sad path? Well, the answer is neither. So left is sad path, error happened. Right, happy path. So here in these few lines of code here, I've defined, well, if it was successful, do this, map right. Otherwise, map left, show an error notification. You get full type safety with it. I'll show, how are we doing on time? We got 50 minutes. Let's do it. All right. So I have a little example prepared for this. But if you're interested in functional programming, I definitely would recommend checking out this library here just to play with it. And the guy has an excellent blog series as well that I highly recommend reading on the subject. So, all right. I probably should have killed, hopefully I'm on my port. All right, let's fire it up. Okay, so to add a little bit of context, so I'm very much into smart home stuff. So I bought a bunch of Kindle Fires on Prime Day, and I've been wiring them throughout my house. So I have little tablets that control all my lights in my home. And so I needed to create a UI that could basically, I could tap on different tiles and turn lights on and off in mass. And so with that, I have a little progressive web app I wrote that these Kindle Fires can render. There we go, perfect. Yep, so you can see I have a little scene set up here. So this movie, I hit a button and all the lights in the living room turn off and the kitchen under, lighting turns on dim so that people don't trip over things. If I get home, I want to turn all the lights on, turn all the lights off, that kind of stuff. So if we get back into the code behind here, so these scenes that I'm rendering here, so as you can see as I hover, so come on TypeScript, this is kicking up. Let me restart. Actually, this is good for me to go over. So if you ever get types that you don't think look right, you can always restart the TypeScript server as you saw there. So sometimes with VS Code, it'll give you hiccups sometimes. If it seems to be taking a while to come back or something like that, you can essentially kill the TypeScript language service and then restart it. That's the command you use to do it. Yep. So you can see here, so whenever I'm accessing the endpoint here, I'm getting a task either back. That represents as an operation that may or may not succeed. If I get If it all goes according to plan, I get this listings response back. Otherwise, I get a string. That string is an error message. So if we go over here, see, so I'm mapping left here. And so this is where that string is coming from. So this is the sad path. I'm catching within a promise. Why would you do this, you may ask? The reason being is that I may not want to throw in, exceptions are hard to handle, right? You don't really have a lot of choice. Whenever you're throwing an exception from a method, you're kind of, you're trumping everything and you're throwing an exception. People have to catch it, but that's expensive. I may not want to, not all errors are created equal, right? I may want to just show like a tiny little notification and then try to handle it a different way. This is a great way of handling it. So, we already saw, the tiles here loading in, but what if I intentionally break my code? I will do that.
People don't be turning your lights on and on.
Right, yeah. So, yeah, pets at home, they probably freak out. Yep. All right, so yeah, so you see, so it's mapping left here. So with those few lines of code, I mapped right or mapped left, and then I render a little snack bar down here. But that's what's controlling it. So you see a map right, if I get the payload back, left, and then I get the nice little message at the bottom saying, yeah, couldn't hit smart things. So great library to check out. The author has a great series I'll show you in a second, blog series that kind of explains these concepts, but they're great for business functionality because that's pretty much our livelihood is we're rendering edge cases and stuff like that. So capturing it in the type system allows you to ensure that you didn't miss a case. Yep, so as I mentioned, I put my slides here, a lot of useful resources to reference. I'll post these slides. These are all links to the different libraries. This is the blog series that I was mentioning. So it's the Italian rock climber guy that wrote it. Yep, but he has a great series that explains a lot of functional concepts behind his library, and he's mapped into TypeScript. Highly recommend it. And all right, that's about it. So, yep, feel free. Any questions?
Is there a place we can get the slide deck?
Yeah, I'll see if I can post it to my Twitter. I'll see if I can talk to Pete as well to see if there's some central place. But yep, put that out. Perfect. Yeah, and I'll also put the stuff. I think I have one of the libraries already on my GitHub. I'll link that too. I'm Drew Carver on GitHub, so I'll link that as well. Perfect. All right. Any other questions? All right. Well, thank you for coming.